I'm Al George. I'm a professor and chairman of the Department of Pharmacology at Northwestern University, and I'm pleased to be the local host for the 7th ATP1A3 and Disease Symposium that's being held on our campus this year in beautiful downtown Chicago. The purpose of this meeting, which started just a mere 7 years ago, is to bring together scientists from across the globe and parents and family-run organizations to try to work together to share information about what we're doing to understand ATP1A3 associated diseases, their clinical effects, their genetic background, and the mechanisms of these diseases. So at some point we can pull all that information together and make improved therapies for children and adults with these diseases. From the scientist's perspective, this has been a really good conference this year. We've extended the range of topics slightly. We've wanted to address some of the non-motor, non-movement symptoms that occur in ATP1A3 associated diseases, and therefore have focused a lot on the psychological and psychiatric manifestations of these disorders, including in some cases where psychological and psychiatric conditions such as early onset schizophrenia were the only manifestation of the disease associated with an ATP1A3 mutation. This illustrates what has happened over the last several years, which is the harder we look, the more diversity that we're seeing in the clinical spectrum of neurological and neuropsychiatric disorders associated with mutations in this gene. And so this meeting gives an opportunity for people to share their ideas about the relationship between the diseases, what we call the phenotype, and the genetic abnormalities, what we call the genotype. And at some point in the near future, we're going to have a better handle on the mechanisms that result in this very divergent clinical spectrum. So my laboratory has been mostly interested in two areas of investigation. The first is trying to understand the fundamental molecular and cellular mechanisms responsible for alternating hemiplegia of childhood. To do that work, we have focused on a cellular platform for investigating human neurons that are derived from stem cells that are derived from patients that have defined genetic mutations in ATP1A3. We do this work in collaboration with Kevin S. at Vanderbilt University, and the two of us have been proud recipients of generous funding from the AHC Foundation in the US. But our goal in my lab is to really investigate the electrophysiological consequences of ATP1A3 mutations in human neurons that we generate in the laboratory. This work has led to some recent discoveries about the fundamental abnormalities in the pump that is encoded by ATP1A3, and that has led us to think more about how we might energize the pump to work better. We previously have investigated a number of, I should say, thousands of small chemical compounds for their ability to activate ATP1A3 in cells and neurons. Unfortunately, that work is not led to any obvious positive findings, and we continue to think about other avenues where we could exploit small molecule discovery paradigms to find something that will activate the pump. We're also collaborating with other groups now to help support ongoing efforts in, say, gene therapy, and we hope to be able to support that using this in vitro cellular platform as a test system for evaluating the efficacy or the effectiveness of new types of molecular therapies. So the progress in this field has been pretty impressive. Since 2012, there's been an explosion of discoveries of different genetic mutations. There's been this increased awareness of the diversity of disease that can be associated with ATP1A3. And I think that progress has been essential for understanding how do we go forward now. To scientists, that seems like really rapid progress. We also have now 4 or 5 different independent mouse models of this disease, which are essential for us to understand the physiology and give us animal models in which to test new therapies. Again, for a rare disease, that progress in a period of 6 or 7 years is rapid. But that's our perspective. We know that from the perspective of a parent with a child with this disease that perhaps has been diagnosed just in the last couple of years, that progress seems really way too slow. And I'll have to emphasize that the scientists don't want it to be that slow either. And so there's an ongoing effort to sort of use the new tools of genetics and biology to try to push it faster as fast as we can. But I want to emphasize that it's important that speed is one element. Getting it right is probably more important. Because if we make a mistake by moving too fast and we come up with the wrong mechanism or the wrong interpretation of an experiment, that's not going to translate into the health and well-being of patients with this disorder. So being cautious, being rigorous, making sure the studies are reproduced, not just in my lab, but in other labs, is the only way forward to make sure that we have something that will translate to an effective treatment. So what I'm most optimistic about is that we are closing in on understanding more about the basic mechanisms of these disorders. And by understanding mechanism, we can then be inspired to find a treatment strategy that addresses those mechanisms. I think we're seeing at this meeting an emerging thought that perhaps gene therapy and other molecularly targeted therapies that exploit new discoveries in biology are going to be used to try to offer new strategies for treating ATP1A3 diseases. But again, if we don't understand the fundamental mechanisms, we could be going down a blind alley. And that's why our lab has really focused a lot on one really essential question, which is in these disorders in which there is one mutation and one copy of the gene that is normal, do we benefit from replacing or inserting a new copy of the gene or not? And that's a fundamental question that we only can answer with experiments in cells, in animals, well before we get to the point of treating people. So differentiating between genetic disorders in which there's a disease because you're simply missing a functional copy of the gene versus one in which the mutation itself causes other problems that you may not get rid of if you introduce a new copy of the gene. That's something we really have to sort out. And so that's one of the big areas of emphasis that we have right now that we're really trying to overcome. Technically, that's called differentiating between haploinsufficiency, which is the condition of missing one copy of the gene, versus the alternative, which is there's a dominant negative effect of the mutation on the normal copy. And in each of those circumstances, the treatment strategy may be very different. I think evidence from this meeting is we're definitely moving forward, and on all fronts, clinical front, genetics, molecular biology, physiology, all of those things will eventually sum together for us to be able to push forward a therapy. This afternoon, we are having a session entirely devoted to new therapeutic strategies where we'll feature progress in gene therapy and molecular therapy. This year's meeting, we have representatives from 2 companies who are interested in therapeutic strategies. One is a pharmaceutical company from Canada, and the other is a molecular biotechnology company from the States, both of which have unique ideas about how one might employ either small molecules, typical of drugs, or novel modern molecular strategies to improve the balance between the mutant copy of the gene and the normal copy of the gene. It's been impressive to everyone who's attended these conferences over the years that the strength and influence of patient advocacy groups is really impressive. I think for a rare disease to get this much attention in the scientific community requires strong and continual advocacy from families and caregivers who know and sense the urgency in getting results. As scientists, we really appreciate that advocacy because it keeps us grounded in knowing why we're doing research, why it's important, and it really is a motivating factor. So I applaud the family foundations that are here and those of you who couldn't come to keep at it and keep on the pressure, keep us scientists aware of what we should be doing and how fast we should be doing it. We do appreciate that and want to work with you to make advances and eventually have the best possible outcome for patients with ATP1A3 diseases.